in here, and we'll go ahead and just get started because we've got a lot of really great content from our two speakers, panelists for our workshop today. My name is Jennifer Chi, and I am part of the OHSU Eventathon team. In my day job, I work at Kaiser Permanente Northwest in market strategy, and various roles in business development and innovation. The outline for this workshop today is first I'll go over some logistics and the agenda, do an introduction to our two amazing panelists, and then hand things over to them to walk through this really amazing workshop they put together. So if you are here for cooking with FHIR, workshop C, you are in the right place. In terms of logistics, just wanted to say, and I think we can put this into the chat box. If you have any questions, please go ahead and write it into the chat box. We will be monitoring that and then reading those questions in the order that they come through. And please do that. And I think we might even be able to unmute folks for that if we need to. We'll be playing things by ear a little bit based on how many we have in this audience. So, and then at the end, we will share a link to a survey for your feedback on this workshop, which is really important because OHSU being an academic institution is also part of an assessment to just look at evaluating these type of events, these hackathons, and what makes them effective and what we get out of it. And so your participation in those surveys are very helpful in us gathering the data that we need. All right, well, let's go ahead and get started. So we've got from our panelists, Daya Sharma and Phung Matthews. They are both Innovator Fellows at Cambia Grove, which is an innovation hub based out of Seattle, Washington. Daya is also CTO at the Handoff Company, and Phung is a pharmacist and a researcher at Point of Care Partners. And Phung is currently with, I think she's at a clinic with a family member who has some medical needs, and so my goodness, Phung, thank you so much for still joining us. She'll be on mute for a lot of the session, and so Daya will be taking the lead on this, and just really appreciate everyone being here and looking forward to learning. Daya, please take it away.
Thank you so much. Hello and welcome everyone. So we're going to be learning some of the basics around FHIR, and I'm going to be using a lot of analogies here. So cooking is the theme here. We want to use fire in the right way. And it reminds me of a saying that fire is a good tool to have as long as you can control it, but it's a bad thing if you cannot control it. So we can cook whatever we want, and so let's start with that. First of all, before we jump into it, I would just like to give you a brief on my background. I've been in the IT industry for slightly more than 2 decades, and in the healthcare industry for about 6 years, and been playing around with FHIR for about 3 to 4 years. I can just say this, that healthcare is on the cusp of innovativeness that we have never imagined, and FHIR makes it all possible. Let's understand how. Health IT has gone through various iterations in advancement. Initially, about 2 to 3 decades ago, a lot of innovation was happening in the provider space and the payer space. mainly from the billing perspective, and slowly started to shift towards value-based care. And with the advancements of the technology and adoption, uh, patients becoming more educated and aware and taking more responsibility of their health, they want to keep track of it. And so patient um, inspired and patient demanded innovation is now beginning to take shape. And so we are just witnessing this in things like the regulatory bodies are, beginning to make it mandatory to simplify the access of the data around the patient health. So that is going to spur more and more innovation. Um, and what we'll try to cover in this workshop is at a very high level two things. One is the theoretical understanding, and other will be a hands-on workshop. And it will be in the hands-on workshop, which will be just a very basics of what you can do with the FHIR. That will be a good opportunity to ask the questions and answers. Um, but in the theoretical section, we will develop a basic understanding of what FHIR actually is and what are the possible things we can do with it. Why is it considered one of the most innovative things to happen in healthcare as far as standards and technology goes? So, without much of further ado, let's start this. So, what is FHIR? Well, FHIR is an interoperability standard that facilitates the exchange of healthcare information between entities such as healthcare providers, payers, patients, etc. And it is based out of the HL7 International non-profit organization, which is an ANSI accredited standards developing organization. What it means is that FHIR is based on standard technology and has gone through extensive vetting procedure all throughout the world, not just in the US alone. Um, so what does FHIR stand for? FHIR is an acronym that stands for Fast Healthcare Interoperability Resources. And the emphasis here is on interoperability, but as well also on fast. Fast here means agile. Like you can turn things around real quick. You can implement um, applications. You can implement the solutions which in like a decade earlier would have taken a year. You can implement that in a month. That is the advancement here. So fast is really fast. Um, and this basically obviously is healthcare specific. The focus is on interoperability through well-known data formats, and we will dive dive deep into it, what it actually means. But the real focus of the FHIR specification, which is actually it is a platform specification, it has been to ease data exchange at the end of the day. All right, so what are some of the key principles around which FHIR standard or the platform specification has been designed? First of all, it is designed around implementation in mind. Means implementers, the developers, the software engineers don't have to go through a huge learning curve to understand why things are the way they are, right? Like what is the clinical mindset behind it. They don't have to worry about those. They don't have to worry about archaic knowledge base. So it is that piece that makes it really implementer friendly. When to support that, there are a lot of implementation guides, the reference architectures that are available that one could follow as an example, and there are lots of lots of connectathons. Connectathons is a nice way of saying it's a hackathon at the end of the day where you can try out newer implementations, um, and the the core of this is that the platform is for the FHIR.
Oops. Is anyone else having trouble hearing Daya?
Yeah, Daya, it seems like you're muted.
He got muted. Daya, you'll need to unmute yourself. Sorry about that.
Oh no, sorry. I don't know how that happened. Sorry. Okay. Where was I last time you heard me?
It's just been about 5-10 seconds.
Okay. Okay. Sorry about that. I don't know if that happened automatically somehow. Okay. So the core is that FHIR FHIR platform specification is designed to support 80% of the use cases in the healthcare industry right off the bat. What that means is that any FHIR capable server would support 80% of the use cases. The remaining 20% of the use cases can be implemented by using concepts like profiles, extensions, and capabilities, and then whoever is implementing that particular use case can actually check whether it is correctly implemented or not. So that's an amazing innovation and the power. Um, and the reason it exists is because it leverages existing technology. Means there is no new format that is coming in that did not already exist. It uses formats that are well known like XML and JSON, which is JavaScript object notation. And this is important because nobody has to learn any new data exchange format anymore. Um, Additionally, it still supports paradigms that were existing in the healthcare industry before FHIR came into being, like the document and the messaging. And I will go deep into it, what that actually means. Um, and primarily, FHIR is based on RESTful architecture, and we will understand what that means. But one thing FHIR did that previous standards and specification could not do very well, at least, was make it human readable. Like not only it is machine readable, but it's also human readable. There is a recommended narrative section, which we will see in a minute or so, that makes it so easy to understand what does this particular data or particular exchange of information means from an end user perspective, like from a patient level or a clinician level who does not understand software. So this makes it really easy to support different paradigm and catering to different users. Also, the key concept in the FHIR is the resource, which is the R part, the last alphabet here. R. The resource is the building block, and we will understand what it actually means. And that supports RESTful architecture. RESTful stands for representational state transfer. What it means is a data exists in a state at the end of the day, and you want to update its state. So you're going to transform from state A to state B. And that is a very well-known paradigm in the web technology. In fact, majority of the web technology is based around RESTful architecture. And FHIR comes with multiple implementation libraries, which means it works with multiple programming languages. So you don't have to, do the heavy lifting on your own. And specification is free to use, so it's almost like open source completely. You can also contribute to the implementations of the FHIR if you are technically inclined. Um, Obviously, it has strong foundation in web standards. Not only it is based on XML and JSON, but it also uses HTTP, OAuth, these kind of well-known and better tested standards. And it provides a very smooth developmental path from older interoperability standards, which were like HL7 version 2 and version 3, the CDA, and so that it is easy enough to transition from older uh, older standards to the new one. And all of this is possible because it supports the different paradigms and architectures, and we will explore that more. So just wanted to emphasize the human readability. So just to give you an example, this slide that you're seeing right now is HL7V2 showing an observation result of a glucose, blood sugar glucose. And this is an ORU message for those of you who know. And this is, to me, it's not at all human readable. Like, I understand the word, glucose, but I don't understand what everything else means. Maybe 182 is the level, but everything else is just very hard for me to understand. So how does this, how has this been solved in the FHIR specification? Let's see an example. Okay, so the equivalent representation of this particular observation of the blood sugar is shown on the right hand side here in this resource type called observation. And now I'm introducing a concept that I have not talked about as yet, but ignore that for a second and concentrate on the text written in the red font or the red font. So it shows the value, and this is not the exact matching of the data, but it is highlights a very important point. A, you can easily read it, even if it is machine friendly, it is much easier to read. And secondly, the important part is the text, which is the narrative piece. This is the human readable narrative piece that is already included in this resource type observation. What that text piece does is that it can be easily parsed by existing tools like the browser that we all use. The text includes HTML, plain old HTML. This is generated on the fly by a FHIR capable server, and it represents the data in a human readable format, and the other attributes are the ones that contain the data in the machine readable format. So just wanted to highlight this. So this is easy for a doctor or even a patient to read, at least in the sense of the value and the reference ranges, much like you see in your lab reports. Okay. So first, let us go a bit deep on what are the resources. What is a resource? Resource is the smallest unit of exchange. It is an information model at the end of the day. It is a way to package things, way to define a graph of information, which includes things like the data elements, which are the attributes, and what are the constraints on them? How do they relate to each other? How do they relate to other resources? Or the terminologies, which are nothing but the coding systems being used in your particular implementation. A coding system, some of you may know, like Loink or SNOMED. So resource is that smallest unit that represents all the data elements, the relationships, the constraints, and the terminologies that are used. And this is used of obviously in as a building block to create or to implement the use case specific to your business needs. Um, and This is pretty much analogous. Again, as I showed in the previous example, this is pretty much analogous to the version 2 of HL7 and the version 3, um, which included the common message element types. And if you want to see what are the different resources that are already implemented and the maturity levels on each one of them, you can go to this link, hl7.org. This lists all the resources that are available right now in version 4 of FHIR. Version 4.0.1 specifically is the one that the regulatory body CMS and the governance on that the ONC recommends to be used for implementing the mandate for July or January 1st, 2021. And this list can be seen in multiple ways. One is you can see it from, like, if you are a security person, you can see it categorized by the security. And you can also see it by like alphabetical, or you can see it in terms of the financial, the clinical, and things like the most important thing to me is if you are implementing from the conformance side, like what does a FHIR server conform to? Like what are the uh, what are the restrictions and what are the things that are allowed by a server? So I can look at those things, and just an FYI, the word N, sorry, no, not the word N, the alphabet N on each one of the names here that you see, that is representing the maturity level of a resource. What that means is N means normative. Normative means this has gone through extensive battle testing in real world production settings for at least more than 20 instances or so are already out there, and that's when it is reaching the maturity level N. Before that, it could be in multiple levels, and you can go to the tab which says by maturity, and you could see which one is in the trial use, which is the level before the normative. So the reason I wanted to highlight this was not every resource is normative, means it is not completely yet standardized. There is still work going on in advancing it and making it flexible enough to adopt to more of the common use cases in the industry. Then there are resources that you can see by the committee, which is the working groups that are working on in refining the specification, and the members of the working groups are generally the vendors or the providers or the payers, and they participate in coming up with the standard. So it's a very open technology forum. Just a quick example. I think I already showed this, was like an example of observation resource. In this case, we are talking about heart rate, which is a vital sign. You could represent the same resource either in XML or the JSON. This one shows patient resource in XML. So those of you who like XML more than JSON for some reason, you can use XML also. But I wanted to highlight four important parts here. The first part, which includes the ID and the meta tag, is the very specific to this particular instance of the resource, and specifically the metadata or the meta tag includes things like when was this resource last updated, or it could also include the version ID, means each resource has different versions of it. So every time a resource is updated, a new version is being created, which means you can access the history of the changes on a record, on a resource, which is very important for auditing. Then the metadata, which is still the green tag, the green section up there, also is used to represent the profile that a particular resource conforms to. A profile is a fancy way of saying the constraints that are applicable on a resource, or the extensions that the resource can support. It could also include things like the security and the tags, which means like what does this particular instance of the resource relate to in a clinical workflow. Then the narrative piece, which is the human readable summary, which I already showed to you with the blood glucose example. And this is, even though it's not mandatory, it's highly recommended that the implementation supports the generation of a human readable summary of every resource. Then the third part is the extensions, which means how can I extend the capability of a resource? Like, for instance, if some use case is very specific to my needs and the resource does not support it, FHIR allows you to extend that resource to meet your need. For that, you have to specify the URL where the resource definition, which is the structure definition, or the extension on the resource, which is the structure definition, exists. In this example, the extension is the trials. So this is coming from the population health, or it could be the trials that you participate in. So in this case, renal is an example of this patient with the ID of glossy is participating in. Then the last section is the standard data, which means the data that is really applicable to this particular resource. In this case, for the patient, the demographic, the basic name, address, birth date, all are very important. And of equal importance is the organization to which this record belongs to, which is the provenance. Like, where was this record even created? So even that kind of information is captured. Let's talk a bit about extension, since I just mentioned it. Extension is, as I said, it's a way of extending the core capability of a resource, something that is not supported in the platform specification. It can hold arbitrary value, ideally that something that you want to use in your use case. It could be integer, string, there is no restriction on it. And you can also define an extension to be used by any resource, and we will see an example of it real quick. Let's talk about what are the profiles. What does it really mean? So profiles are nothing but a set of constraints that can be imposed on a resource through the usage of structure definition, and they are included. They are specified, as I mentioned. They are specified in the metadata section of a resource. Like, which profile does this resource conform to is declared on the resource itself. And the profile is one way to basically either restrict or extend the operations, like what kind of search can you do on a resource, or what kind of modifications are allowed. And this could be important for many reasons. One is to be in compliance with the regulatory requirements of your state or your local, authorities. So this is one way of implementing. Profiles are used extensively um, to meet the local requirements and the business use cases. Some of the examples of extensions is like if you wanted to search a resource by when it was actually created, like in a real world, you have the EMRs, and EMR they use some proprietary databases, and then they send the data to some kind of an interface engine, where the interface engine can further send the data through some message broker architecture to your end to an application, let's say. But the application wants to know when was this data um, created, not when it was received. So you could extend all the resource by creating an where where the attribute name itself is, let's say, by uh, search by provenance date. And we will show an example of an extension also when we have a hands-on exercise. Some of the examples of the profile, and I think I can show this real quick, is the patient profile. This is implemented by the US code, which is the implementation guide, and I will explain what that means. But in this profile, it is saying what the patient record must have. It must have an MRN, it must have a name, it must have a gender, and it must support these things, right? So you cannot have a patient resource without having an MRN, for example, and you cannot say, I'm not going to support ethnicity, right? So those are the constraints that are imposed in this particular profile, which is a part of the US Core implementation guide. And you can go into the details of it. But let me come back to the presentation. Okay. And there are other examples of the Argonaut profiles. Actually, the implementation guide is considered the collection of the profile. So profile you can think of in terms of the cooking analogy as the spices. So collection of spices is and the ingredients are being used to create the recipe, right? So implementation guide at the end of the day is a collection of the actually it is a recipe that you can use to implement your use case. In this case, it is a collection of the profiles and the conformance that is required to be met. So it is basically designed to solve a particular problem, particular business use case, and it is generally implemented with enough documentation to make it easy for the developers to implement that particular use case, which is matching or which is being met by the implementation guide itself, right? So and implementation guide actually happens to be a resource in itself. What it means is, just like we saw the observation resource and the patient resource, implementation guide is a resource in itself, which means it is computable, or it is a computable definition. It holds all its logical parts in it. What it means is you could easily run some validations on it. Like, how do you know that your implementation conforms to that particular implementation guide? So and there are many implementation guides and many test scripts that can be run on the implementation guide itself. Okay, so what exactly is an implementation? What exactly is in an implementation guide? There are basically two high-level things: resources and the narrative. The resources are including the profiles and extension definitions. It also includes, as I said, the test scripts, the capability statements, that what would you get, what would your server be capable of, what would your application be capable of once you implement this implementation guide, right? So that is the capability statement. It also has the logical models and the relationships between the resources. It also lists the coding systems being supported and the values in the coding system. For instance, if you were using Loink, you could eliminate some of them because it does not, let us say, apply to your use case. Then it also includes the narrative piece, which is the domain analysis. Why was this implementation guide created in the first place? What use case does it meet? What were the drivers that brought this implementation guide into existence? And some of the diagrams, like the UML diagram or the business process notations, are used to then document the thinking that went into creating this implementation guide. But at the end of the day, implementation guide is an executable tool. It can be executed on your endpoint. Some of the examples of implementation guide is US code, which is the biggest one, which is specific to US. And other countries have their own implementation guides, and there is a whole implementation guides registry, a list that you can access at this URL at the bottom. US code is important for everybody who is implementing anything in the US. CMS and ONC, they mandate using the US code implementation guides, and there are many implementation guides that come off of this implementation guide. So you can create implementation guides based on a implementation guide. So this is very interesting. So what are some of the paradigms that the REST platform specification supports? Obviously supports REST paradigm, which is a nice way of saying it supports HTTP verbs. What that means is it supports post, put, get, delete, and patch. These are the verbs and are nothing but actions that can be invoked using a tool, and that would cause some kind of the transformation of the data. Or it could be just a reading of the data, like a just fetching. The RESTful interface is a very well-known interface on the web. So that is one thing, and that is the primary way, the most high-profile way of exchanging the data in the industry at this point in time. But to have backward compatibility, messaging and document are also supported. If you have seen HL7 v2, you would recall that there is a MSH segment, which is the message header. To support the similar paradigm, FHIR specification supports messaging paradigm in which you can actually specify a message header, which by the way, is a resource in itself. So you can specify that and then include, just like we have the segments like OBX, PV1, or the PID, all these segments one after another. Similarly, you can put in the resources below the message header. So that's how you achieve compatibility in terms of architectural compatibility with SL7v2. Similarly, document is a way of packaging resources in a document format, which is similar to the CDA architecture. And this is like applicable in the use cases like discharge planning. Okay, in which when the patient is being discharged, in many hospitals still the patient gets the whole file of what happened to them, what was done to them, and everything. So that document could be, or actually needed to be created in many settings, and this paradigm supports that. The service-oriented architecture is not really a paradigm, but it's more of achieving an architectural solution using REST messaging and or document. So just wanted to highlight that FHIR adds to the flexibility, does not take away anything. Now let's just real quick jump into some kind of a hands-on exercises, and this would be a good point to start asking some of the questions. But let me lay down the framework within which we will do some hands-on exercises. Toolboxes. What are we going to use? The tools. First of all, the most important thing is a publicly available server, a FHIR compliant, a reference implementation of FHIR is available on this server called happy.phir.org. So I'm going to just open this here just to highlight that right now this is basically a non-authenticated public server in which you can access all forms of data around the patient, observation, and everything. And we will jump into it, but let me take a step back here. Apart from the server itself, what are the tools we are going to use to send the data or to receive the data from the server? There are two options. One is desktop installable and other is on the web. For the purposes of this demonstration, I will use the last option, that is on the web, because so that you can also try it out if you want to right now. So that is the hands-on part. So the URL at the bottom, reqbin.com, is what I will use for the demo. But I will also switch a bit to show how the desktop installable tools like Insomnia and Postman work. So let us just dive right in. So let's go back to the happyphir.org public server for a second. Here I am going to pull up on this particular endpoint. I'm going to pull up a patient record just to show that it works. Okay, so I already have a patient record, but I wanted to just highlight some of these search capabilities that are already included. Like I can search patient by name. So when I click on search, this is by the way the same base URL, the happy.phir.org, and I'm on this reqbin.com, which is the web tool to issue the HTTP verbs and do the RESTful play. So this publicly available FHIR server is being queried for a patient resource which has a name Johnny. So when I click send, I'm using a get call, which is the get is a HTTP verb, a fancy way of saying fetch the data. Basically, I want to read it. So here I receive a bunch of text here, but let me just break it down. This says resource type bundle. Now you may be wondering, like, wait, I wanted patient. Why am I receiving bundle? Well, it just so happens that the name Johnny is common. In fact, it's slightly less common than John, but that's why I did a search with this. And it says that there are about 25 records that match the name Johnny. Obviously, that's not very good, but it also gives me the first 20 in this particular result set. So this result is like an envelope of all the possible patients that are in the system with the name Johnny, right? And each entry is a patient resource. So I can see here that this is a resource of the type patient, and this is the internal ID, which if I want to, I can further use to query the patient. But let us say I already knew the name, the last name, which is the family name, and I knew that this was Sparkles as an example. So let me do a query of that, and boom, I get only one patient record. Total return is 1, and it is Johnny Sparkles. So as you notice, this is case insensitive search right here, and I also get the ID of this particular resource. What that means is I can access this resource directly without going through a search parameter based on attributes, right? So right now I search for name, and when I search by name, I'm searching for anything that matches either the family name or the given name, right? So, but I could directly go to that particular instance by ID. So I just copied the ID from here and searched it, and I get the very same record now without the wrapper of the bundle. Okay, so this is how I would fetch. And now if I wanted to, let us say, create something, create a patient, what I'll do is I will do a post request. Let us see if I can do a post request here. Content wise, I'm going to post this very same thing. I'll remove the ID because ID would be automatically be created by the system. I don't need meta because that's not what I want. I want to just create something for my needs. Let us say I'm going to create Daya Sharma and family name Sharma, and right. So I get that, and I have Daya, and I'm not going to share how old I am. I'm going to just keep it like this. So okay, and it created one right here. This is the ID that the server issued to me. What that means is I can go here and now do a GET request to fetch the same record, or I could go back here and search it by name. So I could go back and say name equal to Daya, and it fetches me the same record now wrapped in a bundle. This is like an envelope. So this is a very basic way of fetching a record. You could search it by different means, and to go to the list of the search parameters that are available, I would like to highlight a very important piece here, which is required to be implemented by any server implementing any FHIR implementation guide. Any implementation must support this endpoint called metadata. What that does, it fetches the server's capability statement. And it's important because with that I can now go and query. Actually, it will be better to now switch to this particular tool called Insomnia for me to highlight that particular very important piece about capability statement. So I just use the same get call to the metadata, and I get the very same thing. Here I can easily search for, let us say, patient, like what are my restrictions or things that I can do to a patient, or basically a patient resource. So the kind of interactions that are supported on a patient resource is read, update. VRead is a version read, like I can fetch a particular version, or I can delete the patient record. And I can, of course, create, I can fetch the history on it. Okay. So this is how I can query the capability of a server and go to each of the resource that the server supports. So if the server is implementing a particular implementation guide, it may not implement all the resources, right? For instance, what's a good example? Questionnaire may not be applicable to a particular use case, right? So you don't need a questionnaire resource as an example, or maybe, what's a good example? Condition may not be important for, let us say, data analytics that you're trying to run. So you could specify in your implementation guide that, this is what I want, right? And you will only, get that in terms of the capabilities of your, server, whoever is implementing that. So this is just one example. Then the search parameters are like what is supported on this particular resource. So here, as an example, I could do a search by email, right? I could do search by given name. I could do search by organization identifier or death date or whatever, right? So there are many ways that I can search, and these are all supported in this particular patient resource, in this particular implementation. So this is just one example of querying the metadata. And metadata is giving me the capability statement. Plus, I can go and look at the structure definition used to, actually this is misspelled. Yeah, okay. The structure definition used to create this patient resource or the constraints on the patient resource itself. So let me go there and see patient. So this is just a reference of it. So this is not the real one, but let's go here and see wherever it is defined. Right. So structure definition. In this case, again, this is referring to the type, type patient. Basically, every resource is defined in terms of a base resource, which is also an instance or a kind of an instance of the structure definition. And in this case, it is defining the elements that go in creating a patient resource. So we can see identifier, name, telecom, address, and so on and so on. These are the elements that we see when we query a particular patient resource. So that is the data that we saw being returned. For instance, for the ID that we just saw, and I don't remember the ID, but I can search by name, right? So I can again go back and say name equal to Daya, right? So these attributes or the elements are the ones that are specified here, right? Name, for example, right? So patient name is max is 0, means the patient may not have a name, as in the case of John Doe, right? So that's what I wanted to highlight in very basic hands-on exercise. And then let's also do some exercise on observation. So let me go back to the public server and see which patient has an observation.
Daya, as you're doing that, this is Jennifer, just letting you know we got about 5 minutes left. No questions currently in the queue, but definitely encouraging folks to put that
Sure.
in there if you do have any last minute questions, and we'll be wrapping this up soon. Thank you.
Okay, yeah, thank you. So going back here for a second, let us say I wanted to fetch the observations on this particular patient, right? So the way I'm going to do this is let's say, I think this supports patient ID, or actually patient equal to, let us see if I can get something on this. Okay, 0, because this is, I just created this particular patient. It does not have any observation. But if I went back to the previous example, where actually what I'm going to do is I'm going to just look at the observation resource real quick and see which one exists here. Okay, so for example, if I just read this particular observation, this is on a patient with ID of 50 as an example. So if I go back here and try to fetch observation now, I should be able to do it, or I can do it in another way, which is a good to know, is okay, patient.id maybe, and let's try this. Nope, no, that's not supported. Okay, so let us go back to patient with ID 50. First of all, let's make sure that is existing somehow. Oh, that does not exist. Okay, so that patient actually was deleted in this case. We can see. So let's try something else here real quick. Okay, what's going on?
And after you do that, Daya, will you summarize any kind of concluding thoughts and comments for us? We've had some questions about, again, just like what was like high level for the newbies out there. Maybe even hearing from you, like where have you used it in a practical application?
Right. Yeah.
Like
absolutely. Yeah, absolutely. So actually, because we have only a few minutes left, I'm going to switch gears in actually just showing you that you can also do a query real quick on patient, and then $everything should be supported on this. Let us see if $everything fetches me everything on the patient. Right. Okay. So $everything is an operation that I can invoke. Is supported by on almost all the implementation guides that I know. Basically, it's a way of saying fetch me all the data related to the patient. I don't care whether it is observation or condition or whatever it is. So in this case, I was able to fetch observation. I was able to fetch, well, just a bunch of observations right now, seems for this patient. But you get the idea that you can fetch pretty much every data on the patient by just doing $everything on that particular identifier. Okay, so where do we go from here? Well, smart on FHIR is very important to know, because that's how you build applications, patient-centric or provider-centric, and there's much more than what I can show here. Basically, this is smart technology being used on FHIR to make applications portable. Basically, you can substitute one application for another in case the other one is much more enhanced. So it makes it really easy. You can go to this URL, apps.smarthealthit.org, to see a lot of these apps that have been designed and how the app launch works. How does it use authorization and authentication? I don't have time to show it right now, but real quick, where do we go from here? Try it out, play around with it, fulfill a use case. In the company where I work at, we have used it for discharge planning. We've used it for handoff, for transition of care. At the end of the day, the communication piece is what everybody is trying to achieve, right? So in our specific needs, we deal a lot of it with the conditions and observations around a patient, and the care plan and the discharge planning. These are all represented in the FHIR resources. So just a quick high-level view of what you can explore on this. So I would like to thank you for your time, and if you have any last-minute questions, please feel free to ask.
Great, thanks. Yeah, it seems like maybe Daya might have a couple of minutes to stay on if anyone has any specific questions they want to talk about. Otherwise, I am putting into the chat. It's been up a few times. I'm going to put it in again. just about a 1-minute survey where we a workshop questionnaire. We'd like your feedback because we are collecting information on basically what's been helpful to everyone during this event. And I know that I have learned a lot more about FHIR than I knew coming into this. So Daya and thank you so much for this. It's very, very helpful. Phung, thank you as well for assisting in the chat. And everyone, if you have any follow-up questions, as Daya said, the contact information is posted. And Daya, are we also posting the file that you gave us as well, or do we have that?
Yeah, I will send you the link to that. It is a Google slide deck, so you can just have access to it in a second. But I can just answer this question real quick. Somebody's asking about, would it be fair to call FHIR a way of formatting data? Actually, it's much more than that. It is a way of specifying the data and way of specifying interoperability. It is not just a format. Format is the JSON, which is the way of representing the data in a JavaScript object notation. What it means is JavaScript basically runs the 99% of the web out there. And so FHIR is not just a format. It is a platform on which it's a foundation on which you can build everything in healthcare right now. I don't have time for any other questions, I guess. So thank you.
Thank you, everyone. Yes, if you have any, again, there's contact information available, and then if there's something about this relating to your pitch that you're thinking about incorporating, then you can also send an ask out to the mentor support channel. And from there, we can see if there are mentors who have that background who can connect with you and help you. Thanks, everybody. Appreciate you being here.
Thank you.
Thank you, Daya.
Thank you very much. Bye.